Welcome back to my YouTube channel. Let us continue with the chemical equilibrium. So in the previous video, I mentioned to say the chemical equilibrium, it is a state where the forward reaction, the rate of the forward reaction and the reverse reaction is the same and they are both taking place at the same time. Okay, now there is what is called the equilibrium constant, where sometimes you have to calculate the equilibrium constant, or you have to find the expression of the equilibrium constant. So in this video, you're just going to learn on how to find the expression of the equilibrium constant. Okay, so now for you to express the equilibrium constant, we'll start with this general equation, just the illustration. Now the equation must be balanced, so we imagine that these numbers I'll put in and these letters I'll put in red. We imagine that these are the numbers from the balanced chemical equation. So here we'll put a small letter A, we'll put a small letter B, here a small letter C, and here is a small letter D. Okay, so to find the equilibrium constant expression, we need to use the same subscript, in one way or another. So in this case, you say the constant equilibrium, which can be represented by the letter K, then EQ as a subscript for equilibrium, is equals to, now you express the product in terms of the reactants. Okay, so you get the products, which are, now you have to put them inside the square bracket. So C, that is, open the bracket, then you write C, then you close the bracket. Now on top of this square bracket, you have to put the number which is in front of this compound. So in this case we have C, so C to the power C, then times D to the power D. So these letters, remember, they are just representing the numbers which can be there. Okay, over now the reactants, again the same thing, you put the square bracket. So A to the power A multiplied by the B to the power B. Okay, so this is how we find the expression, the equilibrium constant expression for a chemical equilibrium, or for the chemical equation. Now the actual equation which we have, I have 3 of them here, so we'll be going through them one by one as fast as possible. Okay, so I'll use the other part, I'll use the other paper. Okay, so for equation 1, where we have A, 3 hydrogen plus nitrogen, then forward reaction there to produce 2 molecules of ammonia. Okay, these are gases. Okay, so they want us to write the equilibrium constant expression for this reaction. Write the equilibrium constant expression for reaction A. So we are going to find the equilibrium constant in terms of the product and the reactant. So we do the same thing. This will be the equilibrium constant is equals to, if you want, you can just use the letter K, it's okay. Equilibrium constant is equals to, you open the square bracket, the product, you only have one product here, which is ammonia. So NH3 to the power, on top put the number which is in front, the coefficient, in short, the coefficient of this compound, which is 2 in this case, the power 2, over the square bracket, we have hydrogen gas to the power, the coefficient which is 3, multiplied by nitrogen gas to the power 1. So if you want, you cannot even show the 1, you can just leave it like that. Okay, so this is the equilibrium constant for reaction A. That is the equilibrium constant for reaction A. Okay, now we go to B. Okay, so if you look at B, we have carbon monoxide plus hydrogen gas to produce that compound. Okay, so the same things apply again. we have carbon monoxide plus 2 molecules of hydrogen gas to produce CH3OH. Okay, so what you are going to do, this one is already balanced. Even this one is already balanced. Usually they will give you the balanced equation, but if it is not, you have to balance it. Okay, if it is not, you have to balance it. That's very, very important. Okay, so again, we're going to do the same. We say the constant equilibrium or equilibrium constant is equals to the product, which is the CH3OH, okay, to the power 1 over the reactant, square bracket open, carbon monoxide to the power 1 multiplied by hydrogen gas to the power 2. Okay, so this is the equilibrium constant expression for this reaction. So these are quite easy, they are very simple, but sometimes we need to know how to calculate these, either in terms of concentration, in terms of volume, of which we'll be looking at them one by one in the next videos. Okay, so now we go to C. Now the reason why I had to put this is because here we have two products. Here we had one. Now here we have two products. We have the nitrogen dioxide and the oxygen gas. So either in that case the process is the same. So for C, you write down the equation. We have 2N2O5 plus there's no plus, sorry, it's just a forward reaction, okay, to produce 4 nitrogen dioxide molecules plus oxygen gas. Okay, we want you to draw or to come up with the equilibrium constant expression. It's not different from this, it's the same thing. So the constant is equals to, in terms of the product, we start with the product, so the square bracket, okay, the square bracket where we have nitrogen dioxide times the coefficient, which is 4, multiplied by oxygen gas times the coefficient, which is 1. Here there's 1 in front, okay, and then over, open the square bracket, we have N2O5 to the power the coefficient, which is 2. So this is the equilibrium concentration. Thank you for watching. I hope it has made a little more sense, and if you have questions, leave them in the comment section below. Please help me to make better videos by requesting for some videos which you want to be uploaded and where I can do better. Okay, thank you so much for watching. Even if it's your first time to watch my videos, please do not forget to subscribe. Please share this video so that we may become big in this family, where we'll be watching videos together, learning and discovering new items. Okay, thank you so much.